For example 4, we run into the dreaded fraction. And it tends to be the part that most Algebra 2 students don't like the most, so we need to make this an easy process. So when you see fractions, especially whenever you're trying to solve an equation, the best thing that you can do is to just simply get rid of the fractions. We'll eventually maybe have fractions in our final answer, but what we're going to attempt to do is find simpler terms to work with. And the way we do that is by finding a least common denominator. So you'll have to go back to a little bit of middle school math here to recall least common denominator, or LCD. But the easiest way to do this is to just simply look at the denominators that are given. Now in example number 4, we have 3 completely different denominators. We have 3, 4, and 6. And so we need to find a multiple of each of those that's the least common. So if I just sat there and wrote multiples over and over again, I would just gradually keep on working up. And then I could do the same thing with the 4, and then I could do the same thing with the 6. And then so what we're looking at here is the least common multiple that they have, or in this case it's a denominator, since they're all denominators, is 12. And so what I want to suggest that you do is that you're going to multiply both sides by 12. If you remember the golden rule of algebra, if I do something to one side, I have to do it to the other side. What this is going to do is going to create the effect of eliminating all of the fractions. So if I multiply 12 times 1/3, I'm going to multiply the 12 times the 1, which is going to be 12 over 3, and then 12 divided by 3 is 4. So that's going to leave me 4x. And of course I have to distribute that value, so if I multiply the 12 times 1/4, I'm going to have 12 times 1, which is 12, and divide by 4, which is going to give me 3. So then I have 4x plus 3. Then I have to distribute on the other side, so I have 12x, and then I would have 12 times negative 1/6, which is going to give me negative 2. So if you remember, for example, 12 times 1/3, so just for simplicity here, that is the same thing as having 12 over 1. And so 12 times 1 is 12, 1 times 3 is 3, and of course that equals to 4. And that's how we ended up with our 4x. So now what you see here in this third step is just a normal equation with whole numbers and integers and no fractions to deal with. And so we can work our way down until we isolate x by itself. Now you notice the final answer does have a fraction in it, but it was much simpler to deal with at the end than it would be to deal with a fraction in every single step. So, least common denominator is a very important process that you're going to want to know how to do. And so we call this clearing the fractions, which is a very effective way to solve equations. And you may use this technique in a lot of other problems later on in the year. So, go ahead at this time for sample problem number 4 and see if you can use LCDs, least common denominators, to help clear the fractions and make these easier equations to work. Alright, as we look at sample problem number 4, part A, we get a little lucky here because my least common denominator is simply 4. We have 4 there and 4 there, so I don't have to really do like I did in the example problem and find the multiples of 3 different sets of numbers. So I'm simply going to multiply both sides by 4. And of course I have to use parentheses so that the 4 gets applied to every term in there. So if I'm going to use like a little L, backwards L little technique here, what I'm going to do is I'm going to multiply 4 times 5, which is 20, and 20 divided by 4, which is going to tell me that I have 5x. And I'm going to go ahead for the purposes of this problem, go ahead and write that whole part, and then I would have 4 over 4. And then of course the 4 times 5 is 20. When I divide that by 4, I get 5x. Same thing here. When I multiply the 4 times 1, I get negative 4 with the negative, and then divide by 4 leaves me negative 1. So now I need to simply bring the x's to the same side, bring the whole numbers or the integers to the same side. So if I subtract 4x from both sides, I'm left with x over here. And if I subtract 12 from both sides, I'm left with x is equal to negative 13. So this is how we can use the least common denominator to clear the fractions and make it a lot easier to work. So if we look at part B, we're dealing with a lot more values here, so I'm just going to kind of come down here to the side. I have a 2, a 3, and a 6. So to find the least common denominator, what I'm truly finding is the least common multiple. So if I do 2, 4, 6, 8, I can do 3, 6, and 9, and then I have 6. And so you can quickly see that 6 is the least common denominator or least common multiple for this. So I'm going to multiply 6 to both sides. Now, it just so happens in this problem that I have fractions spread out across the entire part. Now this time, instead of doing it in 2 steps, I'm going to do it in 1, and I'm going to kind of use that little backwards L technique. So I'm going to say 6 times 2 is 12. 12 divided by 3 is 4. And then, of course, we have to bring the x. Then I have 6 times 1 is 6. Divided by 2 is 3. And, of course, we had a negative there, so that's technically a negative 3. Now, this is pretty simple because the 6's are going to simply cancel out. But let's watch what happens. 6 times 7 is 42. 42 divided by 6 is simply 7. And now 6 times 1 is 6. Divided by 2 is 3. And, of course, we're bringing the x with that. Now what I'll do is I'll consolidate the x's on the left side. I'll subtract 3x from both sides, so that's going to leave me x on the left. And if I add 3 to both sides, it leaves me 10 on the right. And I have my final answer of x equals to 10. So hopefully by doing the least common denominator, you will eliminate fractions and thus make the problem easier to solve until the end, where you may or may not get fractions as an answer. Okay, I hope that helps you overcome your fear of dealing with fractions. For example number 5, we're going to be dealing with a word problem, or what we sometimes call an application problem, where we're going to apply our knowledge of solving equations, in this case, to a real-world example. So let's take a look at example number 5, and we'll kind of walk you through how to work these things. It says a real estate broker base salary is $18,000 a year. And I can tell you from personal experience that $18,000 a year is not a lot of money. She earns a 4% commission on total sales. How much must she sell to earn a total of $55,000 total income per year? So, what we have to first figure out is this. It's always good to write what we call a verbal model. Just kind of spell out what your equation or expression would look like depending on which one you're working with. And so what we have down here is we've basically created a verbal model. And we can just basically say out loud, my total income is going to be a result or equal to whatever my base salary was, plus whatever my commission rate is, times my total sales. Now, my commission rate times my total sales technically represents my total money from the commission. So I could even simplify this verbal model even further. I could say that my total income, and I'll just abbreviate that, is equal to my base salary plus my commission earned. And so what we can do is we could do a simpler verbal model, or we could do a more detailed verbal model. Either way gives you something to work with. Now what's good for that is, and I sometimes like to put that first and then take what we have and apply all of the individual parts. And so I now know that I'm looking for a total income of $55,000. I have a base salary of $18,000, a commission rate of 4%, which is written as a decimal, and I'm looking for my total sales. So we can then replace or substitute the parts in the verbal model that we have numerical values for, and of course we can replace what we're looking for, the total sales, with the x variable. And then we would have a linear equation that we would go ahead and solve in a normal fashion. And when we solve that, we see that the broker must sell $925,000 worth of real estate in a given year so that she can earn $55,000 a year. Now, I know at this point in your life, $925,000 worth of real estate must sound like a lot, but if you really think about it, at this point in time in 2013, that the going rate for most houses in Baton Rouge ranges anywhere from $200,000 to $500,000 a piece. So this lady could technically sell 2 $500,000 houses, and she would have earned that much money for the year. So, good real life example. Many of your parents may be in the real estate business, and they would understand this example perfectly. The rates may be different, their base salary may be different, but the example is very relevant. So let's bring this down, and let's change the scenario a little bit to maybe something that you might be doing in college in a few years. Sample problem 5 describes a situation of a waitress who earns a base salary, but then also receives tips on an hourly basis. So go ahead and take an opportunity to work sample problem number 5 and use the previous example to guide you. First thing I want to do, I'm going to read this problem and see if I can come up with a verbal model that represents the scenario. It says a waitress has a base salary of $3 per hour, makes approximately $15 per hour in tips. How many hours must she work to make $135? Well, first off the bat, whatever it's asking me to find, that's typically going to represent my variable. So let's talk about this. We're looking for total pay. Alright, so we're looking for a total pay, and my total pay is basically made up of my base pay plus my tip. So that's a verbal model that I can use. Now, if I use the information from the problem, I can see that I'm looking to see how much it'll take me to make a total pay of $135. So my total pay is represented by $135. It says that my base pay is $3 an hour. So this is a rate. So this is the amount of money I make per hour. And my tip pay is also representative of the amount of money I make per hour. Well, fortunately, I know how much money I make, but what I'm missing is my hourly rate. And I can represent that with an H, I can represent that with an X, I can represent that with any given variable. My tip pay is $15 per hour, and again, I don't know what the amount of hours that I'm going to work at this point. That's what I'm trying to find. So I have an equation here. First thing I need to do is to simplify the right side. So 3h and 15h gives me 18h, and then I would simply divide both sides by 18. Gives me h is roughly 7.5, and of course that's representing hours. So what it's basically telling me is at $3 an hour plus 15 in tips per hour, I need to work 7.5 hour shift to make $135. And that is pretty realistic. Since the last time I waited tables, that was roughly what people made. So if you're good at it, you might make more per hour in tips. If you work at a different restaurant, you might make more per hour. But that's a pretty realistic scenario. So that is the way we would apply solving equations to a word problem.